Good morning. We're here today with Daniel Camilleri, founder and chief executive of Bo Robotic Software Engine. Good morning, Daniel.
Morning, Andrea.
Can you please introduce yourself and Bo?
Yes, so my name is Daniel Camilleri. As I say, I'm the founder and chief executive of the Bo Robotics Software Engine, and I am myself a electronics engineer, then roboticist, researched at the university for about 6 years, doing research on the human brain and how we learn, and then decided to apply those concepts into robotics.
Fantastic. Now, I read recently that you have secured some funding. So what are your plans now with the funding?
So we haven't secured funding recently. Last funding was secured in December 2020, 125,000 from the Startup Funding Club. They're great investors. They really believed in our vision from day one. And ever since then, up to today, we've sustained ourselves with income from different projects.
Fantastic. And can you tell us more about the relationship you have with the Nuclear Decommissioning Authority?
So the Nuclear Decommissioning Authority, we had a contract project with them alongside the Defense and Security Accelerator. Just last year, we won 2 contracts, both within nuclear decommissioning and also within providing medical assistance in hazardous environments. And the role of the project was to demonstrate the full potential of teleoperation technologies. That means you have a robot that is in one location in a hazardous environment often. In the case of nuclear decommissioning, it's potentially exposed to radiation. In the case of medical assistance, it's potentially exposed to contaminants like chemical, biological, or again, radiation. And the robot's there, but the person is somewhere else altogether, so that the person with the expertise to perform those tasks is completely remote, completely safe, but they can still carry out those tasks at a distance. And the whole scope of the project was to see how far can we push the technology and how far can we build on our platform in order to deliver these applications. And so what we've done is we've used the software engine we've created to integrate haptics, so the feeling of touch, the feeling of force by the operator, so that they can know how much force they're applying via the robot. Very high field of view vision, so that it's like being there yourself. And also different methods of movement so that you can address any situation as it comes. And all of that builds upon the very low latency communication that our software provides, and on top with it, so you can swap different pieces on the robot side without changing any code on the operator side. And that is crucial to what's missing in robotics today, because what is missing is a layer that will allow these two things to be independent, the hardware and the software, because at the moment they're too coupled. So changing one device means you also need to change the whole software, all the software along the way. So that is the piece that's really allowed us to iterate quickly and deliver much more than otherwise possible in a.
Fantastic. Well, in an interview, you mentioned that there are only 150,000 skilled roboticists. Now, what do you think should be done to potentially increase this number?
So that number is the sum total of roboticists, both specializing in hardware and in software, that have come out of universities today. And as it stands with the existing software, that number can only increase by increasing class sizes, by increasing the attraction of robotics and driving them through a master's program, an undergrad program where they specialize in robotics. But what we're doing is something completely different. Instead of keeping robotics as is, in terms of something that is very difficult to learn, it's very difficult to access because robots cost so much, and instead make it something that is freely accessible and easy to learn. And that is what our Bow Robotics software engine does. It turns robotics from something that you would need a master's level and then 4 months to learn a robot into you just need to be a developer, probably even just secondary level programming in Python, and then 2 days to learn how to use our SDK, and you can work it immediately with a simulator. You can simulate the robot and create your applications. And a lot of people will say, well, simulators already exist. You could already do simulated robots and create your applications there. But the problem with simulators is that the way that you program a simulated robot is very different from the way you program the physical robot, even if it's the same robot. So our software even solves that problem, giving you a universal approach to programming simulated robots, and that software then seamlessly transferring to the same simulated robot, the same physical robot, or even different physical robots.
Fantastic. Where do you see the company in 2 years? And what do you think you will need to get there?
In 2 years, we will have covered 80% of the robots in the market. We will have SDKs for all 9 common programming languages, working on all 5 operating systems. That is both desktop operating systems and mobile operating systems. And we will see a whole new influx of applications created for computers, apps, web apps even, where there's a robotic component to them. And that app is communicating with a robot and telling it what to do as part of the service that is being provided.
Well, fantastic, Daniel. It's been very interesting talking to you today. And if you would like to know more, please visit the Bow website and contact Daniel Camilleri directly. Thank you very much.
Thanks, Andrea. My pleasure.